So, hello everyone and good evening. Thank you so much for joining us today. On behalf of IMS Xcitium Arabia and Xcitium team, it is a pleasure to welcome you to this leadership session, and we truly appreciate your time and your presence with us. Actually, we are gathered here with a group of cybersecurity leaders and decision makers to explore one of the most critical shifts shaping our industry today: how artificial intelligence is fundamentally changing the cybersecurity landscape and what that means for the future of enterprise protection. In this session, we will move beyond the traditional threat detection and into a new model known as executive governance, where the real security decision is no longer only about identifying threats, but about controlling what is allowed to run within your environment. Today, we are honored to be joined by two distinguished leaderships and speakers, Mr. Melih, the founder and executive chairman of Xcitium, and Mr. Muhammad Aliyan, the chief executive officer of Xcitium Arabia, powered by IMS. This conversation brings together global innovation and regional leadership at a time when organizations across the region are rethinking their security foundations. About Xcitium Arabia, powered by IMS, we serve as the regional extension of Xcitium Global Cybersecurity Vision. We focus on enabling enterprises and governments in the Middle East to move beyond traditional detection-based security and toward zero-dwell and execution governance model that control execution at its core. Our mission is to help organizations strengthen resilience, ensure compliance, and stay ahead to rapidly evolving the AI-driven threats. So, today, thank you once again to be here and joining us. And feel free to type any question that you have in the Q&A here in the chat. And now we can begin.
Hey, thank you so much, Diana. So, hello, everyone. It's a pleasure to be your host for today's leadership session. Before we begin, and on a quick note, today we have an exceptional lineup. So it's not like a product pitch; it's an executive dialogue, one-on-one, a candid, actually, one-on-one conversation about the single biggest and largest shift in cybersecurity that we cannot afford to ignore. We are at a stress point, definitely, in cybersecurity. In the just last 6 months, we have seen AI act as an autonomous attacker. It did weaponize the OAuth tokens. Remember those OAuth tokens? We used to get applications to work together, and that static trust, compromising hundreds of enterprises. And we got a piece of malware that rewrites itself every hour. So the rules have changed. Today, we have the privilege of hearing from Melih, Mr. Melih Abdulhayoglu. He's the founder, as my colleague said, he's the founder, the executive chairman of Xcitium. He has 25 years of building technologies that secure the world's largest enterprises. But not only that, he is someone who has never been afraid to change the industry norms, or probably the right word is industry orthodoxy. He has done it a long time ago when he introduced lots of rules to protect and secure browsers, and he's doing it again today for endpoint security and detection-less capabilities that he introduced to the market. So he's with us today to address that topic, which says, if the attackers today are already using AI at machine speed, this is not theory. This has already happened. This already happened. If they use it at machine speed, how do we defend? Melih, over to you. Like you want to say hello to the audience before we start our questions?
Thank you very much. Thanks for having me. Great audience. Thank you. Hi, everybody. So, love to talk about that. It's something very close to my heart. So, I love talking about cybersecurity. I've been in cybersecurity literally since I've known myself. When I was a kid, I used to build, things so that my siblings couldn't get into my bedroom and all that stuff. Alarms used to go on. So cybersecurity is very close to my heart. And there are shifts that happen in cybersecurity, right?
Right.
So cybersecurity started with, in 1980s with a very small someone writing an app, and then someone built a cleaner, and that's how antivirus started. And that was good till about 2005, 2010. Then we needed more visibility. And that's when EDR came to place. And then browsers allowed more stuff to come in. Browsers became a window into your computers, right? So
Hmm.
that became a door for new stuff to come through. But all this new stuff was in a file. File was coming in. So EDR was able to look at a file and all that stuff, which was all good. And now we have AI. Now, when you say AI, it's not simply that the bad people using AI, but AI also exists on your computer. So there are different threat models. Threat model of your adversaries using AI is a different threat model than you running AI on your computer. And all of them is a problem because it's new. We haven't solved it yet. Just like cars, in 1950s, 60s, people used to die from 30 miles an hour speed. Why? Because the ecosystem wasn't there to protect them. And then seatbelts came, then ABS brake systems came. AI is like cars in 1950s, it's brand new. So what are the problems with AI? AI is beautiful, there is no problem, but it's problem if it's used badly. There is no guidelines yet. There is no guardrails. So let's start with a very simple problem of AI. Oh, the uh, adversaries using AI to speed up finding vulnerability. That's a very simple, basic thing, right?
Right.
Now, if you look at it, that brings an asymmetry in the marketplace. So the days of finding a vulnerability and then vendors fixing was okay. People find a vulnerability once a month, great. And
Mhm.
then vendors spend 2, 3 months to fix. So that was operating okay, right? But
Right.
now with AI, you're able to find vulnerabilities much faster, but vendor speed cannot match the speed of people pushing malware. So it creates an asymmetry. AI has made them really, really fast. So could you say that someone like vendors can also use to do patch management? Yes, they can. But the difference is the adversaries, the malware people, ransomware people, have, let's say, 10 times the speed, but the cybersecurity vendors and all the other application vendors maybe increase the speed by 50, 60% because they have a lot more rules. So asymmetry is there. And that's why in the US, we had the, you know, stock market and everybody, had meetings about how to protect themselves against this asymmetry. So that's problem number one. But that is one simple problem. I call it the simple problem. It still is a big problem, but technically speaking, it's a simple problem. It's just speed. The other problem is how the whole cybersecurity industry watches is based on a file. There is a file, we analyze a file, right?
Mhm.
Okay, that's how it's been since 1980s. A file with malicious intent comes in and does something. Okay, great. With AI living inside my computer, there is no file. There is AI. All the intelligence All the capabilities are inside the AI brain. Here's a
Yes.
question. When you see, let's say, Claude Code AI or OpenClaw or any other AI, when they issue an instruction in your computer, let's say it's a write instruction, write this. How do you know? Where is the context? There is no context. So it blows open how today's EDRs work. EDRs are about context. Context is gone. It's not in a file anymore. It's hidden inside AI brain. And guess what? EDRs don't have access to EDR brain. And that becomes a big, big, big problem as well. So you have three main problems here. Problem number one, speed in which AI people can, the malware people can operate much faster than what we can operate as vendors, right? Two, it's no longer a file anymore.
Mhm.
It's inside the AI. It's like a browser. When browsers came, created a big entry into our computers. Now AI came, created a big entry into our network and computers. But the difference is browsers did not have a brain and browsers did not have execution power. Now, imagine a browser that comes in, opens up a door that has brain and execution power. Basically, they control your computer. And we have no means to be able to see if they are good or bad. So that is the world we're living in today.
Yeah, awesome. When this introduction probably allows me to maybe have or lay down a blunt observation, as you mentioned. So we did reach to a stress point where rules have fundamentally changed. And the sad part of the story is that not many of us have fully realized it. Like, for example, as we mentioned, in the last 6 months, the autonomous attacker happened. It's the Anthropic cloud attack, where 80 to 90% of the attack was without human intervention. And to emphasize on the fact that you mentioned about the vulnerabilities and patching them, the OAuth attack that happened with the Salesforce, Salesloft, AWS Drift breach, there wasn't a vulnerability. It was a token. And that token was there, valid for 47 days, and it was compromised, and hundreds of even tech industry players were compromised through that attack. And to make it worse, with the prompt flux attack that Google mentioned in their threat intelligence in 2025, it rewrites itself. It rewrites its code every single hour. So I know, Melih, that you spent like your years saying that detection first strategy or approach is a failing strategy. I cannot
Sure.
imagine how do they do it then? How can EDR deal with that?
It cannot, as simple as that. So EDR can no longer deal with today's threats. Look, EDR did excellent job in 2010 till 2020, 2021. Brilliant. Every product comes, lives, and dies. Are we using fax machines? No. What
No.
happened to fax machines? So fax machine is EDR. And in 2020, antivirus was a fax machine when EDR came. So one thing for sure, is innovation will never stop.
Mhm.
Innovation happens both places, defenders and attackers. They both are benefiting from innovation. So, we have to keep figuring out that there is no silver bullet. Say, oh, if I have EDR, I'm protected. No, 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 no. I mean, EDR is only one small part of the whole equation. I'm not saying don't use EDR. Of course, we need to continue using EDR because there is still legacy stuff.
Mhm.
But EDR on its own is no longer enough. Question I ask people to make a point. Someone comes to your home, knocks on your door. You open the door. It's a total stranger. At 9 p.m., total stranger that comes in, knocks on your door, you open the door. will you allow that stranger to come and live in your home with your children? The answer, they say, oh, of course not. Okay. When a total stranger, unknown executable file or unknown something comes to your network, gets in, why are you allowing it into your network with full access? Then they say, oh, I've never thought about it this way. You see, something unacceptable as allowing a stranger into your home, we laugh at that concept, but we're doing that in our digital world all the time. We're allowing strangers come into our network, and then we say, oh, why did I get breached? Well, because you have strangers living in your network. That's why you get breached. One simple question. Why does ransomware, malware problem exist? Well, because people allow ransomware, malware to come in. Okay, then I ask questions to CISOs and everybody here, right? Why are you allowing malware and ransomware in? Why? Oh, because ADR and other people didn't detect it. You see, so that's the problem. The problem is you are allowing a ransomware, malware to come in. Why? Because detection is failing you. That's why you cannot rely on this legacy systems of detection to be protection. So detection was good as a protection in 1990s, beginning 2000s, even mid 2010s. It's good. But you can no longer rely on detection as your first line of defense. It's done. Your first line of defense has to be virtualization, isolation. That's what you need to deploy. You can only run what is known to be trusted in your network. You can no longer run something that you do not know to be trusted. And that's a big problem. Well,
Great. So for the CISOs that are attending with us, Melih, today, so I can tell from our discussion that the fundamental flaw in the detection first model is the lack of context. It's mathematically impossible to detect, right? And that's why detection is a losing game today. But for a CISO who spent like probably millions on EDR and next generation AV and that kind of stuff, what is the first question he should ask his technology vendor tomorrow, his EDR vendor, if detection is a losing game? What is it that he has to really worry about and not sleep about tonight?
multiple questions. Question number one, how many of your customers were breached? Right? No one's asking that question. You see, cybersecurity vendors, now in the US, if a public company is breached, they have to publicly release that they've been breached.
Correct.
But the company is supposed to protect them, doesn't have to say anything. The guys who's supposed to protect you should say, oh, I failed, right?
Yeah.
Not, right? So the first question that anyone should ask, why are you not releasing your historical performance records? When people want to buy a plane or, the crash ratio of planes, automobiles. Everybody releases their historical data. Yeah? So a cybersecurity company who is not releasing their historical data, you have to ask why. Why? What are they hiding from you? So it's important to ask that question. That's one. Why are you not releasing your historical data? Second question I ask is, how will you protect me when your detection fails? How?
Yeah.
They're going to say, we cannot. Well, okay, then as a CISO, what are you going to do? Right? You're bored.
They just say we're good at detection, but what if you fail?
And let me tell you something about failing. Now, it's a mathematical thing, it's not a marketing.
Yes.
A chap called Alan Turing. Alan Turing is the father of computer science. Okay? In 1936, He wrote, that's like 90 years ago, right? He wrote
Mhm.
a paper called The Halting Problem. It's a
Mhm.
mathematically unsolvable problem.
Mhm.
And that problem has not been solved yet. And if you take that paper, mathematical paper, and apply it to today, what it says is detection can never be 100%. And that's a given, right? Detection
Mhm.
can never
Mhm.
ever be 100%. And if you look at the paper in the halting problem, it's a well-known thing. Go to Wikipedia, you'll find it, right? So detection cannot be 100%. Cybersecurity vendors are not releasing their historical numbers. And when you ask them, how will you protect me when your detection fails? They say we cannot. To that problem, what is your solution as a CISO? Right? So you have to cover that gap. And that gap is covered through virtualization and isolation technologies.
Mhm.
And that problem was a gap this big before AI, now a gap of this big after AI. So that gap has got even bigger after AI.
Hey, Melih, it's a paradigm shift. So
Yes.
yeah, it's easy to prove today that detection is a losing game. Dwell time, I don't like to call it dwell time anymore. I call it dead time.
Yeah, yeah.
It's breach time actually. If your detection tool needs to spend time to detect, respond, and recover, that's dead time. Today it is dead time. That's one side of the story. The second side, when we have those native AI malware variants where you get enormous number of attacks per second at machine speed, and the trust is broken. That's what the sales loft attack taught us. It's not a vulnerability; it's a trust thing. So when the trust is broken, when the speed is machine speed, when detection mathematically doesn't work, and a dwell time is dead time. If we go a little bit technical, I don't want to go that technical, but your patent zero dwell containment with the kernel level API virtualization in simple terms how does it bring that paradigm shift from detection into prevention?
Sure. Well, the key is remember someone comes and knocks on your door at
Mhm.
9 p.m.
Mhm.
You don't let that person in.
Yeah.
And if you want to let him in, you put him in a bubble wrap, then you let him in, right? So if it's inside your home in a bubble wrap, he tries to punch you,
I
he
love
cannot cause the damage.
I love the
So,
analogy.
so we invented the bubble wrap for cybersecurity. So when an executive, so here is a question that we asked ourselves. How can damage occur? So if a ransomware comes in, if a malware comes in, how can they cause damage? If you think it through, if they read something, is that causing damage? Not really.
No,
If they're writing, they're causing damage. So
correct.
what we did is we have a patent, I don't know, 28 different global patents on this. It's a beautiful technology, by the way. And what we're doing is when we see an executable file, because execution is the problem. So when we see an executable file, we look at it. Is it good, bad, unknown, right?
Mhm.
Bad, you know what to do, you kill it. Good, you know what to do, you allow it. The enemy is the unknown. It's an unknown person, unknown guy, unknown executable file. That is where the brand new malware, brand new ransomware lives in a new, brand new, unknown file. We still let it run. We don't stop it. It's not a simple application control. People sometimes conflate application control. It's not. We still allow that executable file to execute, but we virtualize all its write privileges. So ransomware comes in, we automatically virtualize all the write privileges. It reads, but when it's trying to write, it writes to a fake hard disk. So it doesn't know that. So this way, usability is not interrupted. Users are still using the application because this unknown could be a legitimate application. And security is there because we have not given what's important to a ransomware, which is write privileges. Now, I'm sure some CISOs will say, yep, how about I read and I send through internet? Well, yes, excellent question. But we also cover that. If it's an unknown, it doesn't have the privilege to write to internet, i.e. has ability to send something. So that's how we provide security without relying on detection. For us, detection is not protection. For us, virtualization is protection. We virtualize, we protect that way. So that's how we do that.
This is genius, Melih. Before Xcitium, I always struggled with the concept of zero trust architecture on operating systems. You know, ZTA, ZTNA is a big thing in our industry. Access, identity, it's everywhere. But for operating systems, where you have a default deny, you have a default deny. That's what zero trust is. How do you get things working? And you guys brought it in a genius way where, yeah, we deny, but we don't really deny. We wrap you
Right.
in a bubble wrap, and then we control what you write. We let you read. We put you in a different universe.
That's exactly right. So technically, to technical people, I'm sure your audience will understand when I say this. Now, there are two security postures: default allow, default deny. Okay, so default allow, when it comes in, I allow everything by default.
Right.
Default deny is I deny everything by default. Let's say if I'm a bouncer in a nightclub, I allow everyone to come in unless your name is in the list. So come in, come in, come in. Oh, no, you cannot come in because you're a bad person. But the ones that I let in is all default allow. A different model, different nightclub is I will only let people in if you're in the list. So that's a default, and I'll deny everybody unless you're in the list. Now, those two are beautiful architectures, but neither one of them is good. They're beautiful, but either one of them is incomplete. Let me explain you why. Default allow is great for usability. You don't want to deny applications from users, but then that has a problem of allowing unknowns. Default deny is great, it's more secure-ish, right? But usability is gone. So what we've done is we've created default allow usability with default deny security posture. That's the holy grail of security.
Yeah.
So default allow usability with default deny security is what we've done.
Yeah, that's the genius in it. And you do it at real time also, like which is really genius. So if I
I mean, that's
extend,
why
yeah,
that sorry to interrupt, but that's why you see transparency is everything in security. Yeah, if you want to establish trust, you have to be transparent, right? So if you have a problem, you tell people you have a problem. If you know, so transparency is
mhm,
key. Without transparency, there is no trust, period. So, as a cybersecurity company, how can we expect people to trust us if we don't share with them our historical results,
yeah,
right?
yeah,
And because we've got amazing technology, because we collect a lot of data, we also release, we call that transparency page.
yes,
Last 5 years now, we've been releasing our transparency page to people so they can see how many infections our customers had, if any, and how many unknowns that we see, how many of them turn out to be malware, so you can see all that. Why? Because without transparency, there is no trust. Why would you trust a cybersecurity vendor who doesn't trust you to share that information?
yeah, yeah.
So
This is,
that's
yeah, this
that's
is
what.
unique about Xcitium. Guys, you can just Google Xcitium transparency page and you will find the results like on weekly basis back to 5 years. And it all transparent. They led the industry with that concept. I want to really extend a bit also on the zero trust architecture concept, but I want to bring it from the open claw attack, the exposure, open claw exposure, which exposed like if I'm not wrong, like 1,800 instances, that kind of stuff. But what it taught us is that AI infrastructure itself is now an attack infrastructure. So does the Xcitium zero trust architecture extend not only protection to users, but also the AI infrastructure, like AI agents and, with their sensitive tokens and, that I keep saying a lot to people, if you hire me, you don't give me lots of privileges because you don't trust me. But if you hire an AI agent, you give it all the, all the access and the tokens and all of that. So does that architecture expand to AI infrastructure too?
The answer is yes, but let me give you some things that we all associate with. Now, what if all CISOs were allowing all their users to install any browser that they liked? It would be bad, right?
Mm-hmm.
So that would be a shadow IT, right? That would be a whole. So shadow AI is a big problem.
Yeah.
So we do have a shadow AI solution that we're launching in July, but that's only one problem. We also have trusted AI modules that we launch ourselves, secure trusted modules. So put that aside. OpenClaw, what OpenClaw did, you're running code internally on your computer, right? That has access to everything
Mm-hmm.
and it can do anything. Yet the instructions as to what it's doing, it's hidden inside its brain. So that becomes a problem. This is why, so we treat AI like a browser. There is no difference from our perspective. If a browser is trying to write something, we know to create isolation for it. So we treat AI no different than a browser. That's how we need to look at it. But AI is a lot more capable than a browser. But the threat model is very similar. And so we treat AI as like a browser whereby we virtualize what it does. In the future, what you will see is we will introduce prompt level security. So you're going to be able to say these prompts can run securely because at lower level it's good. What it generates, it's good. So OpenClaw, for example, or any other local-based AI will bring different layers of security that sits on top, either validating users or their scripts, so that we can trace the trust all the way from top, all the way to execution of write instructions. So all that is happening, but we treat it like a browser, and that's how we solve the problem of likes of OpenClaw, local AI running on computers.
Yeah, which is again prevention. As simple as that.
You have to. I mean, look, the problem is detection. If you look at it, who said detection will work? No one said detection will work. Detection just happened to be there. So if you look at the history of how the whole industry is using detection to provide protection, where does it come from? Who invented detection as a protection? It's in 1987 or 1986, I can't remember exactly when. The guy wrote a simple script to detect and clean existing virus those days. That's it. Then McAfee made it big. So this detection is not that everyone got together and thought detection is great. It's just happened to be that. Do you know the story about horses' backside
You
and
told me about it.
brain?
I'd love the audience to hear about it. Yes.
Okay, okay. How much of it is true? I think it's true, but we'll see. So the rail tracks and horses' backside. Now, rail tracks Why are they at that length? They're at that length not because someone said, oh, this is the best length for a train. That's because trains had to go under bridges. And bridges, before trains were invented, was designed for horses, carriages. So basically, how big was horses' backside is those bridges are designed to allow them. And as a result, we have the train tracks match that. So horse's back is deciding train tracks. That's how detection came about. Detection is like horse's back. So it
Yes.
came about because it came about, not because it was the best answer.
Yes, I agree. And like if I maybe change the hat and wear the hat of a CIO instead of a CISO, like a Chief Information Officer, and extending what you mentioned about the shadow AI workforce in general, um, which is in simple words, you get unmanaged LLMs, agents, and everything else, which your employees are spinning up every day, whether you like it or not. So how does what you guys launched and what you're developing now under the Xcitium managed AI technology, how does that help enterprise leaders answer the question, who is governing my AI?
Right. So look, AI is important. Everyone should use AI. Literally, everybody should use AI. So I'm a believer in the AI technology and its benefits. Every new technology will have problems that comes with it. You invent new technology, initially security is all afterthought. Yeah?
Yeah, yeah,
Technology comes, causes problems, then we fix it. Same, cars, people die, we fix. So AI is important. We should allow people to use AI. But the minute that you have unmanaged shadow AI infrastructure on your on your network, you have a problem that's so very difficult to solve. Yeah. You have to start giving them the ability. You can't say don't use AI. You need to give them an ability to use AI. So, how does an enterprise use AI? Now, businesses know how to employ people. We know how to employ people. We employ people based on a role. Oh, I need an HR person. I need a salesperson. I need that person. We know how to employ resources based on roles. Enterprises know that. What we have done is we've built an AI framework, AI platform based on roles, so
mhm,
that an enterprise can actually come interview an AI for a role, press button, and deploy it internally. Role-based AIs. That's what businesses need. And this becomes a managed way of getting AI into your workforce, all secure, structured, better way and cheaper way, to be honest. Because the general purpose AI doing role-based stuff is going to be very expensive. You're not going to be able to afford the tokens for it. So having structured, not only more secure, better, easier, but it's also cheaper. And that's what we have done. That's how the managed AI makes its way to enterprises currently.
If I add also, Melih, like between a CISO and a CIO, but CISOs have always been through that mindset of best of breed of stack of technologies. We know that with the prevention first technology we have, we're ready for AI native attacks. But if you look at it from CIO's point of view, they're terrified from the point of that they're worried that the prevention first security could be a blocker for innovation. Is it fair to say no? It's actually an enabler for safe AI adoption. Can I have that conclusion from your statements?
Look, it depends what you use.
Hmm.
If you just block everything, I agree with the CIO, it's a blocker.
Hmm.
So this is why you need to be able to use technologies that doesn't stifle usability.
Hmm.
And so the innovation in what we have done is about empowering, enabling usability so that CIO is happy that when executive team is trying to use things, they can. When HR team is trying to use things, they can. So that's the whole point. Security has to be an enabler. Anyone can build security that stops people. That's easy. The trick is not building a security that stops people, but building security that enables people. And that's what we believe we have done. It's about enablement technology. And our security is about enabler.
Yeah, it's genius marriage between default deny and default allow, and the genius combination of how to make sure that they cannot write, they cannot execute what harms you, but yet your business goes on like usual, and even at a better pace or speed if we can do. Right. If we go back again to the because things will get worse, Maria, with AI at machine speed again. I repeated it a million times, I know, but because it's really a scary thing. If an organization does not adopt a prevention first of the zero dwell architecture, what do you think their future would look like in, I don't know, 12 months, 18 months from now? How do you see it going?
So I can't predict exactly, is it 3 years or 5 years? But at least next 5 years, I see the speed of AI adoption. I mean, we're seeing now in our threat labs, all of the underworld are getting into AI speed. We can see the speed is increasing. It's not peaked yet. So that peaking is going to happen. I mean, now all these people are taking all the open source apps that people use, applying AI to find vulnerabilities in it and attack, etc. So we're seeing the next 5 years, it's going to be harder and harder and harder. And you'll have companies like us trying to build protection for it. But next 5 years, it's like the most important time for your security is when there is a paradigm shift. That change, you have to be alert during that change. Once that's settled down in 3 or 5 years, it's all good. You know what you're doing. But right now is the most dangerous times. Next 3 to 5 years are the most dangerous times because we don't know a lot of things that the AI brings in. So that's where the paradigm shift that you talked about, and that's where the risk comes in.
So the attack surface is enormously vague and
It's an
dangerous.
unknown as well. It's really, really big. It's, and it's getting bigger, and people are using it in very creative ways.
Right. So from Xcitium's point of view, and specifically for you, Melih, like as you have been a pioneer in the space like for nearly three decades. So what gives you the confidence? First, what gives you the confidence that Xcitium will have the answer for the next waves, the 3 to 5 years waves or waves of threats? Or what keeps you up at night? What gives you
Sure,
the confidence and what keeps you up at night?
sure. So the confidence comes in us not following the industry, but always taking a look at the root cause problem.
Mhm.
So it's not about detecting, it's about preventing the execution of unknown, i.e., writing malware. So we we as an engineering organization, we employ a lot of people. We have a different mindset of not following, but finding root cause and finding solutions to those root cause. So that's how we look at the world. And that gives me confidence because when a new problem comes, there is always a solution
Mhm.
if you know how to look at the problem. If you look at a problem from a different perspective and find a solution, if you simply follow what everyone else is doing, you'll never solve the problem. So I have confidence in our team and our abilities. And our patents show that. We continually generate patents. So we have the ability to innovate. How long that will last, I don't know. But so far it's been lasting and it's going, so I have confidence in that. What keeps me up at night used to be my kids when they were babies, but they're grown now. So what keeps me at night, there's a big disconnect between the knowledge that the CISOs need, CIOs and CISOs need, and cybersecurity experts have. There's a big gap. Yeah. So that gap, it's knowledge transfer is a big problem. You see, CISOs and CIOs are doing an excellent job with the information they know. If there's a new information available that they don't know, they cannot act on it. When that new information is provided to them, they're very good. They act on it. So how does that gap matched? That's knowledge transfer. I mean, right now, I am sure there are CISOs here that didn't know who Xcitium was and what our technology was, right? How can we expect them to protect themselves using our technology if they didn't know we existed, right?
Right.
So that's a big problem between CISOs and CIOs and new tech, and it's not just us. There are other technology providers. So how do we bridge that gap between the C-level people and new innovation in the marketplace?
Okay, awesome. So also quickly, if you give us like an idea on the innovation path going forward with Xcitium, because Xcitium does lots of unique things, prevention first, detection less, the first to bring that to the industry, the first successful zero trust architecture for operating systems in the industry. But also you do cloud native application protection. You do now you have that managed AI and AI security in general. What is coming? What do you expect? Maybe with
We don't look at it as a product.
Mhm.
We look at security as an ecosystem, and we protect enterprises. What I mean by that is an enterprise manifests their existence as LAN. They have people working in office. They have cloud computers in some cloud providers. They have people on the road traveling on their laptops.
Mhm.
They have web presence, right? So they present all these presences in different domains. You know, just like governments,
Mhm.
they fight on the land, they fight on the sea, they fight up in the air, and now they fight in space, right? And fifth space is the cyberspace, right? So just like that, enterprises have got their presence in LAN, web, cloud, remote. We build a platform natively architected to work together to protect them no matter where they are. It's not about a product. It's not about ADR, AV. No, it's about providing a platform that gives them that security. And that's what we do. So do we have many little products and features as part of it? Yes. Do we continually build new things? Yes. For example, we got shadow AI coming now because they have a need for shadow AI. You know, we launch CTAM, you know, many different capabilities like that. But the focus is how we protect an enterprise no matter where they are. We protect them in the cloud, we protect them in locally. That's the key. And one of the most important thing is that sometimes people think I'll buy best of breed. Now, best of breed works if you're buying cars and everything else, but it doesn't in cybersecurity. Let me explain you why. And that's a big awakening moment. It doesn't work in cybersecurity because cybersecurity is about intelligence. Having two different best of breed products from two different companies that don't talk to each other is irrelevant. It doesn't work. They're not best of breed. They're worst of breed. Having two products that talk to each other shares intelligence is better. So we pride ourselves in building everything natively. Unlike our competitors who buy a SIM company and plug it into them, our SIM is natively integrated into everything that we've done. It's much different than having a SIM that simply gets logs from different places. So everything we do is natively built to work together and share intelligence. That's why we can protect better instead of buying companies and then plug them in. So that's also a very important point.
Yeah, so probably maybe I can summarize this in a value proposition for our attendees and like CISO, CIOs, even enterprise leaders, that today's technologies, specifically detection-based tools, can never stop the threats that are coming today or tomorrow or in 5 years or 3 years. They cannot, especially the AI native malware. You need prevention, definitely. You need zero trust. You need detection less defense. You need tools that natively collaborate to provide you with the necessary protection and prevention. And for CIOs, AI is infrastructure, you like it or not. It's there, it's unmanaged. And with Xcitium Managed AI, you bring that management and governance to it. And yeah, for leaders like business, yeah, go ahead, please. But yeah.
What you mentioned is governance. We are seeing a huge, huge, huge big wave coming in, being driven by insurance companies and auditors right now, called execution governance. Now, here's what's happening. All the frameworks, NIST, this, that, and all that stuff, they say, oh, you should have execution governance, you should know what's executing and all that stuff. But until now, no one has asked proof of that execution governance. Now, attacks are getting bigger. Cyber insurance companies are getting claims. Cyber insurance companies start to say, hang on a minute, show me, prove me that you had execution governance. How do you make sure that this executable file, right, was governed properly and it didn't execute with unfettered access, with full access? And CIOs and CISOs are saying, oh, I cannot. Using EDR doesn't give execution governance because EDR looks at a file. If a file is not bad, it lets it execute. Well, it could be a brand new ransomware it doesn't recognize. It's executing it fully. That's not execution governance. So now there's a big, big, big problem that's happening in the US, and a lot of our enterprise customers in the US are, loving us because of that, for execution governance. So you need to be able to go to your boardroom as a CISO, as a CIO. When you're sitting around a boardroom, you should be able to put your hand on heart and say, I have execution governance. I know every single executable file is working within my execution governance framework. You cannot say that today as a CISO.
Wow.
And that is very, very important when it comes to execution governance.
Oh, that's a major shift of focus, man. Yes, that's a major shift of focus for CISOs specifically. And
Right.
man, time flies so fast with you, Melih. Would have loved to spend more time with you, but I would love, we promise the audience, Melih is there always for us. So definitely we'll get him another time and we'll always learn from his expertise. I can probably, for everyone, and we're open to take questions if you, I don't know, there is 5 minutes left, but I probably can summarize it to everyone in a way, and correct me, Melih, if I'm wrong. Detection is a losing game. That's it. When malware can rewrite itself non-stop every hour using AI, waiting to detect is waiting to fail. Simple as that.
I
And
agree. It sure does well. It sure does well, but it's a different world now. I agree.
it's a different world. And the dwell times the time that comes with detection is an absolute dead time. It's an absolute breach time. We shouldn't call it anymore. And the Anthropic attack taught us that. The attack moved at machine speed, enormous number of requests per second. They compromise their own agent, their code AI assistant. They compromise everything. They made the platform attack itself. And for CIOs, AI is infrastructure, and unfortunately, it's not managed. So you have shadow AI agents or workforce, whatever you want to call it. Who's managing them for you? Who's governing them, as Mr. Melih said? And what is that execution governance piece? Who's securing them? No one is there. And the sales loft attack taught us that static trust is broken. And when I say static trust, like OAuth, who thought that OAuth could cause such a major attack that happened to Salesforce and its customers? And it wasn't a vulnerability. It's not even something that you can patch. And maybe we can say that AI today, even your own AI, like what happened with Claude and Anthropic, can be used against you because AI agents can be jailbroken and they have the brain, and the brain has the malware in it. There is nothing to analyze. There is no script or file or yeah, there's no files or detection. Unfortunately, we have 3 minutes, guys. If we can take some questions if there is anyone. Yeah, I think there is one here. In what development environment was Xcitium's solution designed, and was there an AI involved? I'm not sure if I get. Yeah, go ahead, please.
Yes and no. Yes and no. So because we've been developing this since 2018, before AI, but now we do have an AI first mentality with humans in the loop for validation. So we very much use AI, and I encourage that, but with humans in the loop. So AI hallucinates, and AI is a weakness as well. So you have to be careful how to use, you know?
AI hallucinates, it drifts. The concept sometimes drifts between the input and output, so you gotta have human in the loop.
You have to
Um,
right now you have to have human in the loop.
you're right, yeah. Awesome. With this, we conclude this session, Melih. I cannot find the words to thank you for supporting our region and for the insightful session with you. And thanks to everyone, guys. You always make our sessions bright and beautiful just because of you. Thank you so much. And looking forward for our next discussion, Melih.
Thank you very much. Same here. Look forward to it. Thank
Thank
you,
you,
guys.
guys.
Thank you.
You guys
Okay.
have a great day.
Thank you.
Thank you.
Bye-bye.
Bye.
Bye.